Hello students, this is Sandhamali, your physics tutor for NEET 23. We have started a last minute series, so let's start our session.
0.6 from current electricity என்ன டாபிக் அப்படின்னா சீரிஸ் அண்ட் parallel connections of resistors. ஓகே, ஸோ ஜென்ரலாக இந்த டாப்பிக்கை பொறுத்தளவுக்கு இதில் பவர் எனர்ஜி இந்த ஃபார்முலாஸ் எல்லாமே யூஸ் ஆகும். அண்ட் சீரிஸ் அண்ட் parallel காம்பினேஷன் நமக்கு ஆல்ரெடி தெரியும், ரொம்ப பேசிக்கான விஷயம் தான். அதை பேஸ் பண்ணி ப்ராப்ளம்ஸ் டிஃப்ரெண்டாக எப்படிலாம் கேட்டிருக்காங்க அப்படின்றது நமக்கு இந்த ஒரு சீரிஸ் ஆஃப் ஒரு செட் ஆஃப் 18-19 ப்ராப்ளம்ஸ் ஆர் தேர். ஸோ அதை சால்வ் பண்ணி பார்த்தனாலே நமக்கு எப்படிலாம் ப்ராப்ளம்ஸ் கேட்டிருக்காங்க அப்படின்ற ஒரு ஐடியா கிடைச்சிரும். ஸோ அந்த ஐடியா கிடைச்சதுன்னா அதுக்கேற்ற மாதிரி நம்மளோட ப்ரிப்பரேஷன் நம்ம கண்டினியூ பண்ணலாம். ஓகே, ஸோ ஃபார் லாஸ்ட் மினிட்ல ப்ரிப்பேர் பண்றவங்களுக்கு இது ஒரு just ஒரு boost up source மாதிரி இருக்கும். Okay, right. The first problem is in the given circuit shown below, the reading of the voltmeter and the ammeter will be. Okay, so listen, in this case என்ன ரெண்டு சர்க்யூட் கொடுத்திருக்காங்க, கரெக்ட்டா? சோ ரெண்டு சர்க்யூட்ல என்ன சொல்லிருக்காங்க? சோ ஃபர்ஸ்ட் parallel connection னா என்ன, சீரிஸ் கனெக்ஷன் னா என்ன அப்படின்றது தெரியும். Okay, parallel connection. Okay, so parallel connection now listen, so there is two resistance. Let me take one resistance and another resistance. This is another resistance. Okay, so this is a parallel connection, so it is R1, this is R2. So இப்படிதான் parallel connection எப்போதுமே இருக்கணுமா அப்படின்னா கிடையாது. So listen, so here parallel connection எதை பொறுத்து சொல்லுவோம் அப்படின்னா potential difference is same. Potential difference is same. Okay, so let me take the example of the above circuit. So இப்போ இந்த சர்க்யூட்ல பார்த்தோம் அப்படின்னா இப்போ ஒரு காமனான ஒயர்ல பார்த்தோம் அப்படின்னா பொட்டன்ஷியல் எல்லா இடத்துலயுமே சேமா தான் இருக்கும். ஸோ இந்த சர்க்யூட்ல இதுல இருந்து இது வரைக்குமே பொட்டன்ஷியல் சேம் தான். வாட் எவர் த பொட்டன்ஷியல் இந்த ஏன்ற பாயிண்ட்ல என்ன பொட்டன்ஷியல் இருக்கோ அதே பொட்டன்ஷியல் தான் இங்கேயும் இருக்கும் இங்கேயும் இருக்கும், கரெக்டா? ஸோ அதே மாதிரி இந்த சைட்ல பார்த்தோம் அப்படின்னா பீன்ற பாயிண்ட்ல என்ன பொட்டன்ஷியல் இருக்கோ அதே தான் எவ்ரி பாயிண்ட் ஆன் த ஒயர் த சேம் பொட்டன்ஷியல் will be there. So B and B because there is no equipment is there. Okay, so now here there is an electrical equipment என்ன இருக்கு அப்படின்னா ஒரு resistor இருக்கு, கரெக்ட்டா? அப்போ what is the potential difference between the resistor R2 is, that is VAB, கரெக்ட்டா? Potential difference is VAB. Okay, which someone will be higher potential. For example, B is a higher potential, mean higher potential minus lower potential, VB minus VA. Okay, that is my potential difference. Okay, here also R1 is also there is a potential difference VAB. Okay, so now the case is now both the potentials are same, isn't it? The potential difference between R2 and R1 remains same, so that is called the potential difference is same, means that then it is called the parallel connection. That is the thing. Okay, and what about its equivalent resistance R equivalent, which is equal to 1 by R1 plus 1 by R2. Okay, generally ரெண்டு resistance வச்சு சர்க்யூட் வந்தாலே நீ டைரக்டா எழுதணும் 1 by R equivalent, which is equal to R1 into R2 divided by R1 plus R2. That's it. Okay, this is regarding parallel connection. Okay, now series connection. Now series connection பொறுத்தளவுக்கு என்ன சேம் அப்படின்னா current is same. Current is same. Okay, current is same அப்படின்றது சர்க்யூட் எப்படி இருக்கும்னா this is my circuit. Potential drop will be C. Here this is a point A and this is my point B. Okay, so now here from this wire is same wire, so everywhere the potential is one only, but there is one equipment R1 resistor is there, R2 there is another resistor is there. Okay, so in between there is another wire is there, so which has a different potential. So this has almost, there is this wire has different potential. Now here the potential is A, here the potential is C, here the potential is B, here the potential is C. Now the potential is different, but the current is same. Whatever the current is flowing here means the same current will be flowing here. Okay, so now what is my equivalent resistance? Equivalent resistance means, see here the circuit involves two resistance. I'm just convert that circuit into simple R equivalent. So this is the point A and this is my point B. So many equipments, so many resistors are there. I'm just converted all the resistor into single resistor. That is called my equivalent resistance. Okay, so R equivalent, which is nothing but R1 plus R2. Okay, so that is the case for a series connection. So now it is clear for parallel connection and what is series connection. Okay, so now come to this point. So first thing is, first look at the first circuit. Okay, so this is a plain wire. So here this is the positive terminal, negative terminal. So this is my point. I'm just taking this is the point A and this is my point B. Okay, what is the potential difference between point A and B is 10 volt. Okay, so same, this is the point A, here it is also point E, correct? So here think about this is also, here it is point B. Okay, this is the equipment, measuring equipment, it won't disturb at all. Okay, point B, ammeter won't disturb the potential. Okay, so this is my point B. So now what about the potential difference across the voltmeter? So voltmeter measures the potential difference. So here this terminal A and here the terminal B. So now it will definitely, this voltmeter measure the potential difference between A and B only. Okay, what is that potential difference is 10 volt. Okay, so now in this case I can say, so V1 is equal to 10 volt. Okay, that is fine. So now come to, this is an equipment. Okay, these are the voltmeter, ammeter or equipment. This won't, and it won't disturb the circuit. Okay, right. So now what about the current? Okay, what about the current? So now the current through the ammeter, here it is I only. So I1 is equal to same I. Okay, I1 is equal to I only. Okay, whatever the current it is flowing through the resistor, it will come again, it will rotate it. That's it. Okay, so now come to this. Come to the second circuit. Second circuit, same thing. So this is A and this is B. Okay, and come to this point. This point is also BA. This point is B, isn't it? So now, what about the potential difference? Okay, see, listen. It will V2 measure the potential difference between A and B only. Okay, there may be a potential drop is here. Okay, so here, see, here A and B is a potential difference between, potential difference across the 10 ohm resistor, isn't it? Isn't it? So same thing here, A and B is a potential difference across the 10 ohm resistor, and this voltmeter is connected parallel with that one. Connector is parallel with the 10 ohm resistor. If it is a parallel connection, mean potential difference will be same. This equipment will measure the potential difference, isn't it? So here it is also same potential A and B and B. Okay, here it is also 10 ohm resistor. Here it is also 10 ohm resistor. So definitely potential will be same. Okay, current will also be same across this one, because both are same resistance and same potential. So current will also be same. Okay, so then I2 is also equal to I. Okay, and V2 is also equal to 10 volt. Okay, V2 is also equal to 10 volt. So I can say both V1 and V2 are equal and I1 and I2 are equal. So simple thing. Okay, very basic concepts. Right. So now the next problem is 6 similar bulbs are connected as shown in the figure with a DC source of EMF E and 0 internal resistance. The ratio of power consumption by the bulb, ரெண்டு கேஸ் கொடுத்திருக்கான். ஒன்னு all are glowing, second caseல வந்து 2 from section A it is glowing and 1 from section B are glowing. So now what is the power consumption? Okay, so this is power kulla formula நமக்கு தெரிஞ்சாகணும். சரியா, power which is equal to V into I in the formula இருக்கு. Okay, power which is equal to VI, and according to Ohm's law படி பார்த்தோம் அப்படினா we know that V is equal to I into R. Correct? So அப்ப power க்கு formula எப்படி எல்லாம் modify பண்ணலாம்? V into I க்கு பதிலா என்ன substitute பண்ணலாம்? V by R substitute பண்ணலாமா? So which is equal to V square by R. So இந்த formula நம்ம யூஸ் பண்ணலாம். இல்ல அப்படினா power which is equal to V க்கு பதிலா என்ன யூஸ் பண்ணலாம்? I into R யூஸ் பண்ணலாமா? I into R into I. So which is equal to I square R. So this is also the power formula. Okay, so power consumption, power dissipation, so இது மாதிரி words யூஸ் பண்ணோம். Power consumption னா, so இப்போ இந்த bulb வந்து ஒரு power consume பண்ணுதா, that is delivered by the source. Okay, so எவ்வளவு power consume ஆகுதோ அவ்வளவு power தான் deliver பண்ணும். So அதுல confuse ஆயிடக்கூடாது. Okay, so we can use this formulas directly. So we will see more problems on power consumption, power dissipation, all those things. Okay, right. So power is over. Now think about the energy consumption. Okay, energy consumption or energy dissipation. Okay, so this is energy is nothing but that is a heat energy. Energy dissipation is mostly heat energy will be dissipated from all equipments. For example, if you take the resistor mean, after flowing the current mean, it will dissipate energy in the form of heat. Okay, so that is the formula is I square R into T. Okay, H is equal to I square R into T. Okay, so which is also equal to I square R is nothing but power into T. So here energy which is equal to power into T, I can use that one. So R I can use V square by R into T. These are the formulas we will be using within the problems. Okay, so now come back to this problem. So இங்க என்ன சொல்லிருக்காங்க, ரெண்டு செட் கொடுத்திருக்கான். So I'm just இப்போ நான் இந்த diagram எப்படி மாத்துறேன் அப்படினா, so this is one bulb and there is another bulb is there, another bulb is there. Okay, 3 bulbs. Okay, identical bulbs, similar bulbs னு சொல்லிட்டான். So identical bulbs எல்லாத்தோட resistance be R. So just take a resistance for all the bulbs be R. So another 3 set, 1 2 and 3. Okay, so which has the resistance be R. So these are connected to one external EMF source. Okay, so this is my question. Right, so now for take the case number 1. Case number 1 is, so all are glowing, all the bulbs are glowing, all are involved in this case. Okay, so now I need to find what is my power consumption. Okay, so power consumption, what is my formula? P is equal to, you can say V square by R, isn't it? R equivalent. So now here so many resistors are involved, 6 resistors are involved. So I'm just converting this into equivalent circuits. See, there is one bulb, that's it. It consumes some kind of power. That power is P is equal to V square by R equivalent. Okay, so this is my R equivalent I have to find. Okay, so now what is my R equivalent? See here 3 resistors are connected in parallel. Correct? So identical resistors formula தெரிஞ்சிச்சுக்கோ. Listen, n identical resistors are connected in parallel means parallel connection பொறுத்தளவுக்கு n identical resistors identical இருந்துச்சுனா டைரக்ட்டா அந்த ஃபார்முலா யூஸ் பண்ண பாரு. R equivalent which is equal to R by n. Okay, அதே சீரிஸ் கனெக்ஷன் இருந்துச்சு அப்படினா சீரிஸ் கனெக்ஷனுக்கு n identical அப்படின்ற கேஸுக்கு n identical resistance இருந்துச்சுனா it's R equivalent which is n into R. Okay, so now இப்போ இது எல்லாமே identical தான். So R plus R everything is, see here these 3 are connected in parallel and these 3 are connected in parallel. So for the first 3, this case, for the first 3 case mean what is my equivalent resistance? That is R by 3. right? And this is the second case, which are all the three resistors, all the three bulbs are connected in parallel, so it is R by 3. Okay, so now these two are identical, isn't it? These two R by 3 and R by 3 are identical only. Okay, these two are connected in series. So then what about my N into R, right? Two resistors. Then what about my resistance is R by 3. So what is my here R equivalent is what? R equivalent is 2 resistor. What is my resistance value be? R by 3. Okay, so which is equal to 2R by 3. That is my R equivalent. Okay, simple thing. So now I can easily write the power consumption. Power consumption which is equal to what? P which is equal to V square. That is my E. Okay, whatever the potential. So that is my E. E square upon E square by what is my equivalent resistance? 2R by 3. It will come up. Okay, so 3E square by 2R. That is the power consumption by all the 6 bulb. Okay, so now case 2. Come back to the case 2 is power consumption which is equal to V square by R equivalent only. But now the case is, now what is my case is only 2 bulbs in from section A. Okay, only 2 bulbs are involved. So it is as a resistor R, as a resistor R, and only 1 bulb in the second case. Only 1 resistor is involved. Okay, so now we need to find the equivalent resistance. For this case, what is my equivalent? Both are connected in parallel. So R by 2, that is my equivalent. So here it is only one resistance R. Okay, now these two are connected in series. Series means just directly add that one. R equivalent which is equal to R plus R by 2. So which is equal to 3R by 2. So that is my R equivalent. So now my power consumption which is equal to, what is my power consumption? E square upon 3R by 2 into the மேல போயிரும். Correct? So now this is my P1 and this is the P2. So I need to find what is the ratio. Okay, then P1 by P2 which is equal to 2E square upon 2R. Oh, sorry, this is 3E square. 3E square by 2R divided by 2E square upon 3R. So இது cancel ஆக போற விஷயம் என்னன்னா cancel ஆகும் அப்படின்னு பார்த்தோம் அப்படின்னா, so E square cancel, R cancel. Remaining is which is nothing but 3 by 2 whole divided by 2 by 3. So கீழ உள்ள fraction மேல வந்துச்சு அப்படின்னா numeratorல reciprocate ஆயிக்கும் இல்லையா? So அப்ப reciprocate ஆச்சுன்னா 3 by 2 வருமா? So which is equal to, so P1 is to P2 which is equal to 9 is to 4. Okay, so my answer is 9 is to 4. Simple problem only. Okay, right. So now the next problem is a filament bulb 500 watt and 100 volt is to be used in 230 volt main supply. So there is one bulb. Okay, just try to draw the circuit, then it is easily we can solve the problem. Okay, so this is, so it rated value is 500 watt and its voltage is 100 volt. Okay, now in my case is, see, it is used with the 230 volt power supply. Okay, so now there is one resistance is connected in series with this bulb and that bulb is work perfectly. It consumes all 500 watt power. Okay, it consumes total 500 watt power from the source. Okay, so now this resistance be R. Now what is the resistance value? That is I need to find. Okay, I need to find what is the resistance value. So here this bulb also has some resistance RB. I'm just taking this resistance be RB. Okay, so now we are clear that 500 watt entire power is consumed by the bulb. So P which is equal to VI, that is my formula, isn't it? P is equal to VI, that is the power consumption. Right, so that is power consumption by the bulb is 500 watt which is equal to how much potential, how much voltage is, which is 100 volt into I. So now current through the bulb is equal to 500 by 100 which is equal to 5 amps. Right, so now the current through the bulb is 5 amps. This resistance is also connected series, so current is same through all the circuit, isn't it? So current is same, that is 5 amps. We can use V is equal to IR also. Okay, IRB. V is 100 which is equal to I is what? What about my I is 5 amps into RB. Okay, then what about my RB is equal to 20 ohm. Okay, so RB is 20 ohm. So now I know this one resistor is there, another resistor is there. So it resistance be 20 ohm, it resistance be R I need to find, and it is connected with the source of 230. Okay, so 230. So now volt. So now I'm just simplifying with the equivalent circuit. So there is one circuit and that is which is connected with the source of 230 volt. Okay, so this is 230 volt. So here it is series connection. So 20 plus R. Okay, so it has a current is equal to 5 amps. Okay, so simple. Okay, potential I know, current I know, so resistance can be calculated. So V is equal to IR formula only. So what about my potential is 230 volt which is equal to I is 5 and resistance is 20 plus R. Okay, so now 20 plus R which is equal to, so 230 by 5. So if you cancel it, mean 4 5 is 20, 46. Okay, so now my resistance is equal to 46 minus 20 which is equal to 26 ohm. So what about my resistance? Resistance is 26 ohms. Okay, right, simple problem only. Okay, So now the next problem is two metal wires of identical dimensions are connected in series. If sigma 1 and sigma 2 are the conductivities of metal wires respectively, the effective conductivity of the combination is. Sigma 1 and sigma 2 are the conductivity. Conductivity we already பார்த்தோம் last video so which is nothing but 1 by rho. Conductivity is nothing but reciprocal of resistivity. Okay. So now the effective conductivity, they are asking the effective conductivity. For that case, you already know the resistivity relation, right? R is equal to rho L by A. So this is the resistance formula we have seen. So from this case, I can write rho which is equal to R A by L, isn't it? I can write like this. Okay, so now two metal wires of identical dimensions. Okay, identical dimensions, both dimensions are same. Okay, are connected in series. Okay, so for first one is a first metal wire has a resistance be R1. So first wire has the resistance R1 and its resistivity be sigma rho 1. Okay, second wire has the resistance be R2 and its resistivity be sigma 2, and its conductivity is sigma 1 and its conductivity be sigma 2. Okay, right. So now it is connected in series, mean I'm just finding R equivalent is equal to what? Series connection mean R1 plus R2. Isn't it? R1 plus R2, because both are connected in series. What about my R equivalent? Okay, so listen, identical dimension mean there is two wires. Okay, so there is one wire, two wires, so which has a length be L and which has a length be L. So area of cross section be A and E. So now I'm just changing it to the one single conductor. Okay, now area of cross section I'm just keeping same. Okay, what about its length? The length is 2L. Okay, it has a resistance is R equivalent. It has a resistivity is R equivalent, rho equivalent. It has a conductivity is sigma equivalent. This is what I need to find. Okay, now R equivalent can be, I can rho equivalent into what is my L. So L is nothing but 2L. Here it is 2L whole divided by what about my area of cross section remains same. Okay, which is equal to R1. So what about my R1? R1 is nothing but rho 1. It has a resistivity rho 1. It has a resistivity rho 2. Okay, so rho 1 into L by A. Right. So plus next thing is rho 2 into L by A. Isn't it? Right. So now my case is, if I simplify this, mean both sides. See, if I commonly take, see here it is rho equivalent into L by A, which is equal to, so L by A common எடுத்துறலாமா, so remaining என்ன இருக்கும் rho 1 plus rho 2. Okay, so L by A both side cancel ஆயிரும். So from this I can say that rho equivalent which is equal to rho 1 plus rho 2 whole divided by 2. Correct. So நம்ம இப்போ எதை பேஸ் பண்ணி சொல்லணும் அப்படின்னா, we need to say regarding with conductivity. அப்போ conductivity பார்த்தோம்னா that is reciprocal of resistivity. So 1 by sigma equivalent which is equal to இந்த 1 by 2 அப்படியே வச்சுக்கோ. இங்க என்ன வரும்? 1 by sigma 1 plus 1 by sigma 2. Okay, so அப்போ 1 by sigma equivalent which is equal to 1 by 2 cross multiple பண்ணோம்னா sigma 1 plus sigma 2 by sigma 1 into sigma 2. So just to reciprocate on both sides, R equivalent which is equal to 2 times of sigma 1, sigma 2 divided by sigma 1 plus sigma 2. That is sigma equivalent is equal to 2 times of sigma 1, sigma 2 divided by sigma 1 plus sigma 2. Okay, so this is my R equivalence. Option C is the correct answer. Simple problem only. Okay, so already be familiar with the resistance formula, right? Right. So now the next problem is, a circuit contain an ammeter, a battery of 10 volt, and a resistance of 40.8 ohm. All are connected in series. If the ammeter has a coil of resistance 480 ohm and a shunt of 20 ohm, the reading of the ammeter will be. Okay, listen. So there is one resistance is said, which is 40.8 ohm, and there is one ammeter. Okay, here ammeter is contains some resistance coil. Okay, so that resistance coil is 480 ohm. Okay, and it is also have some shunt. Okay, some shunt is nothing but which is that is actually an ammeter has one resistance coil along with the shunt. Okay, that is called my ammeter. Okay, so this is my ammeter. Okay, this is my ammeter. Ammeter குள்ள எப்பவுமே ஒரு resistance coil இருக்கும். அந்த ரெசிஸ்டன்ஸ்க்கு parallel ஒரு resistor இருக்கும். அந்த ரெசிஸ்டருக்கு பேர் நம்ம shunt ன்னு சொல்லுவோம். Okay, so this is my 20 ohm. Okay, so now this is connected with the source with the battery of 30 volt. Okay, so this is my 30 volt. So there is current is flowing through it. So now whatever the current is flowing through that will be showing in the ammeter. Okay, now I need to find what is the current here. Okay, so now listen, for finding the current I need to find the equivalent resistance, isn't it? Equivalent resistance. So first consider the ammeter. What is the equivalent resistance in the ammeter? Which is 2 times of, so you may ரெண்டு parallel நம்ம டைரக்டா யூஸ் பண்ணனும். 2 into R1 R2, R equivalent is R1 R2 divided by R1 plus R2. இந்த formula டைரக்டா யூஸ் பண்ண சொல்லிருக்கேன். So which is equal to 480 into 20 divided by 480 plus 20 is 500. Okay, so cancel பண்ணோம்னா 0 0 0 0 கட். So remaining 5 இருக்கும். So 5 ஆல இது பண்ணோம். 48 into 2 is 96 by 5. Okay, so which is equal to 1 5s are 5, 9 5s are 45, balanced 19.2 ohm. Okay, so this equivalent resistance for the ammeter zone. Okay, so which has the resistance is 19.2 ohm. Okay, so now another resistance 48.8 ohm is connected series with the ammeter. So now what is my net? So this is for ammeter. So this is for ammeter case. Okay, so now this is my required equivalent circuit. Okay, so this is 40.8 plus 19.2 ohm, isn't it? Because this one and this one connected in series. Okay, this is 40.8 and this is 19.2. 40.8, this is 19.2 ohm. Okay, both are connected in series, so I can directly add it. So which is equal to 40 plus this is 20, so 60 ohm. Okay, this is 60 ohm. Okay, right. So this is my R equivalent. So its equivalent circuit is like, so this is equivalent circuit is, there is one resistance and there is a source is 30 volt. So this is my 30 volt source and this resistance is 60 ohm. Okay, so now I can find the current. Okay, now I can easily find the current. V is equal to IR formula. Okay, so now what is my I? I is equal to V by R. So what is my potential is 30 divided by what is my resistance is 60, which is equal to 1 by 2, which is equal to 0.5 amps. So what about my current is 0.5 amps. So this is the current which is measured by the ammeter. Okay, so it's very simple problem. Okay. Right, now the next problem is A, B and C are voltmeters of resistance R and 1.5 R and 3 R. So its resistance be R. So and its resistance be 1.5 R, its resistance be 3 R. That is given in the question. Respectively as shown in the figure, when some potential difference is applied between X and Y, the voltmeter reading VA, VB and VC respectively then. Okay. Right, so now they are asking about the potential. Okay, so we can conclude that one thing is B and C are parallel connection, so potential VB is equal to VC. That is clear because parallel connection potential is same. That is clear. Okay, VB is equal to VC. Okay, so from the point we can eliminate option A, we can eliminate option B because VB is not equal to VC and VB is not equal to, so we can eliminate two things and rest of these two will be the either C or D. Okay, both are VB is equal to VC. Now I need to think about what is the potential. So now I'm just taking, this is the current I. Okay, current I flowing through the A altimeter and there is another current which is splitter because parallel connection current is different. So this is my I1 and this is my I2. Okay, and resistance also known. If you find the I1, I2 means we can easily determine how much the potential difference between across the voltmeter B, across the voltmeter C, we can find that one. Okay, so now let me take this case. VB is equal to VC. That is the known thing. So I can write I1 into V is equal to IR, that formula only. V is equal to IR formula is I into what is my resistance is 1.5 into R. So which is equal to VC is nothing but I2 into what about my resistance is 3R. Okay, so if I cancel panna, what is the answer? So R cancel. So inki cancel panna, this will be 2. Okay, so then I1 is equal to 2 times of I2. Isn't it? So I already know that I1 plus I2 which is equal to I, because this I current is entering this branches. Okay, so I is equal to I1 plus I2. So I2 can be written as I minus I1. So 2 times of I minus I1. So 2 multiple 2I minus 2I1. So which is nothing but I1. So this minus 2I1 will coming to the left hand side, up and arrow 3I1 arrow. So which is equal to 2I. Okay, then I1 value is equal to 2 by 3 I. So I1 is this value is 2 by 3 I. Okay, that's 2 by 3 I understand. This 1 by 3 I. Okay, that's I by 3. Okay, ரெண்டையும் add பண்ண உடனே நமக்கு I வந்துரும். சரியா? So இத substitute பண்ணாலே I minus 2 by 3 I is equal to I by 3. That's it. That is my I2. Okay, I1, I2 is found. Okay, now we can find the potential difference. What about my VB potential is what? Across, I mean potential difference which is measured by the voltmeter B. Okay, so that is my I1. I1 is 2 by 3 I into what about my resistance is 1.5. That is my 15 by 10. I can write 15 by 10 into R. So if you cancel me, that is 5 times. 5 3s are 15. Here it is 2 and here it is cancelled. H is equal to I into R. Okay, VB is I into R. So what about my VC is also equal to, see, I by 3. So 1 by 3 into I, that is my current is flowing through that branch, into its resistance is 3R. So which is equal to 3 cancel, remaining is I into R. Okay, so then what about VA? VA is equal to current flowing through that voltmeter is I only and its resistance be R, I into R. Okay, so in all the 3 cases my potential is same, IR, IR, IR. Okay, so here my VA which is equal to VB which is equal to VC. That's it. Okay, so option 3 is C is the correct answer. Okay, simple concept. So now the next problem is 2 rods are joined end to end as shown. Both have a cross-sectional area of 0.01 centimeters square. each is 1 meter long, and one rod of copper wire with the resistivity 1.7 × 10 to the power of -6 ohm centimeter unit is important. Okay, and other is of iron with the resistivity of 10 to the power of -5 ohm centimeter. How much voltage required to produce a current of 1 amps in the rod? Okay, so current is level of flow on 1 amp. Okay, 1 amps current is flowing. Okay, so now how much potential is required? So what about my V? That is the question. Okay, right. So now listen, two materials are given, copper and iron, and its resistivity is given. Okay, and both have the same cross sectional area, that is 0.01 centimeter squared. So நமக்கு எப்போதுமே வோல்டேஜ் வந்துருச்சு அப்படின்னா மோஸ்ட்லி எல்லாமே மீட்டர்ல கன்வெர்ட் பண்ணிக்கோ, அதுதான் பெஸ்ட், அதான் காமனான யூனிட். ஸோ அப்போ which is equal to 0.01 into 1 centimeter is equal to 1 centimeter is equal to 10 to the power of 2 meter, sorry, 10 to the power of -2 meter. Okay, அதே 1 centimeter square அப்படின்னா just squaring on both sides, 10 to the power of -4 meter square. That's it. Okay, so here it is, I can write 10 to the power of -4 meter square. So which is equal to, so this is my area of cross section, keep as it is. Okay, so next thing is each has a 1 meter long, length is given as 1 meter, yes, 1 meter. And the resistivity of copper, RCU, that is, sorry, rho Cu, that is the resistivity of copper is 1.7 into 10 to the power of -6, that is ohm centimeter is here. So I need to change it into meter, so 1.7 into 10 to the power of -6, 1 centimeter is equal to 10 to the power of -2 meter. Okay, so it will become ohm meter. Okay, so then rho of copper is equal to what? 1.7 into 10 to the power of -8 ohm meter. Okay, so now what is my rho of iron? Okay, which is nothing but 10 to the power of -5. This is also ohm centimeter is given, so I can write 10 to the power of -7 ohm meter. Okay, so everything unit is converted into meter. Okay, right. So now my case is, see, these two are, so here it has some resistance R1, here it has some resistance R2. So what about my resistance formula, which is rho into L by E? Correct? So this is the formula I'm going to use here. Okay, so now these two are connected in series. I need to find what is my equivalent, right? So R equivalent, which is equal to what? R1 plus R2. Okay, so which is equal, what is my R1? Which is rho of 1. I'm just taking rho of copper as rho of 1. Okay, resistivity of copper, rho 1 into L upon A plus rho 2 L upon A. So in L ரெண்டுலயுமே identical, the same length, same area of cross section, so don't disturb that one. So L by A is common, so it will become rho 1 plus rho 2. Okay, rho 1 plus rho 2, that is my R equivalent. Now I can find the R equivalent value. If you find the R equivalent value, means you can easily find the V is equal to IR formula use பண்ணி நம்ம கண்டுபிடிச்சலாம். கரெக்ட்டா? L ஓட வேல்யூ எவ்வளவு? 1 divided by area of cross section எவ்வளவு? 10 to the power of -4. So நான் இது எப்படி எழுத போறேன் அப்படினா, which is equal to, see, ரெண்டு digit வெளில வந்திருக்கா, so அப்ப 10 to the power of -6. Okay, 1 into 10 to the power of -6 meters square, 0.01 10 to the power of -6. Okay, 10 to the power of -6 into, what about my rho 1? Rho 1 value is what? 1.7 into 10 to the power of -8. Okay, plus here it is 10 to the power of -7. Okay, so the thing is, 1 2 power 10 to the power என்ன பண்ணிரலாம் அப்படினா சேமா மாத்தி ஆட் பண்ணிக்கலாம். Okay, 10 to the power of இல்லாட்டி காமனா வெளிய எடுத்துறலாம். So 10 to the power of -7 வெளிய எடுத்துறலாமா, divided by 10 to the power of -6 is there. Into here another 1.7 into 10 to the power of -1, here plus 1. Okay, so which is equal to, here cancel ஆயிடுச்சுனா remaining 10 to the power of -1 தான். இங்க cancel ஆயிடுச்சுனா remaining 10 to the power of -1 தான். Into, so இங்க பார்த்தோம்னா this is 0.17 எழுதலாமா, 0.17. Okay, plus 1. Okay, so which is equal to 10 to the power of -1 into, here if you add that one means 1.17. Okay, into 10 to the power of -1, which is nothing but 0.1. So which is 0.117 ohm. Okay, so this is my R equivalent. Okay, this is my R equivalent. So நமக்கு R equivalent தெரிஞ்சிருச்சு. கரெக்ட்டா? அப்ப V is equal to IR formula யூஸ் பண்ணலாமா? V is equal to IR equivalent. Okay, so now I need to find my V. V is equal to how much current it is flowing? 1 amps. 1 into 0.117, so which is equal to 0.117 volt. So this is the potential difference required. Okay, so this is the voltage required to make to produce a current of 1 amps in the rod. Okay, so answer is option D is the correct answer. Okay, now the next problem is, a 12 centimeter wire is given in the shape of a right angled triangle ABC having the side 3 centimeter, 4 centimeter and 5 centimeter as shown in the figure. The resistance between two ends AB, BC and CA of respective sides are measured by 1 by 1 by a multimeter. So the resistance will be in the ratio of, okay, so என்ன பண்றோம் அப்படினா, so first AB, BC and CD மூணு ரெண்டு டெர்மினல் எடுத்துக்கறாங்க. So multimeter வச்சு ரெசிஸ்டன்ஸ் மெஷர் பண்ணும்போது what is the resistance, other ratios என்னன்னு கேக்குறாங்க. Okay, so now listen, if you consider the AB part. Okay, so now consider my AB part. Okay, so AB part பொறுத்தளவுக்கு which has a wire. Okay, which has a wire which length is 3 centimeter. Okay, all are has the same cross section is same. Okay, that is the A cross section, as length is 3 centimeter, 4 centimeter and 5 centimeter. For all have the same cross section. Okay, so now the case is R is equal to, what is the formula? I know R is equal to rho into L by A. So this is the resistance formula. Okay, so now this is my resistance R1, this is R2, this is R3. Okay, now the case of AB means R2, R3 which are in series. R2, R3 which are in series. So R equivalent can be written as. So for the series connection, I can say for the series connection, what is the equivalent? R3 plus R2. Sorry, R3 plus R2, I can write it. Right. So this is a series R2 plus R3 that is in series. So R1 is parallel connected. Correct? So a parallel connection R1 into R2 plus R3 that is a series whole divided by R1 plus R2 plus R3. Isn't it? We know that R equivalent for parallel connection is R1 into R2 for two resistor cases, R1 plus R2. This is the formula. Okay, R2 means that is the equivalent in this case. These two are series R2 plus R3. That's it. Okay, simple case. Okay, so now RAB which is equal to resistance across AB which is equal to R1 is what I can write. I can write R1 is nothing but rho into what is the 3 centimeter, right? So I'm just keeping as 3 centimeter only, 3 divided by area VA into here it is also, here R2 is what? R2 is rho into 5 divided by A plus rho into 4 divided by A, right? Whole divided by what about my R1? Here it is, everything is get added, right? So 3 rho by, so 3 rho by A. So this is the resistance is 3 rho by A. Here it is 5 rho by A. Here it is 4 rho by A. Correct? So plus 4 rho by A plus 5 rho by A. Okay, so now simplify this further means, see rho by A I can commonly take note from these two terms. So it will become rho square by A square into 3. Okay, so I just write 3 into, so remaining is 5 plus 4 is 9 whole divided by, here it is denominator is also rho by A can be commonly taken out. Rho by A can be commonly taken out. Remaining is 3 plus 4 plus 5. 3 plus 4 plus 5 is 7. 7 plus 5 is 12. Okay, so rho by A is cancelled out. So 3 nines are 27 by 12 into rho by A when you simplify this further means. Isn't it? So one row will cancel, A will cancel. So 3 nines are 27 divided by 12 and 1 rho by A is there. Okay, so this is my resistance across AB. Okay, so now resistance across BC. Okay, so in this case BC, let me take, this is my BC. Okay, so here AB and AC are in series and BC and this BC is connected with parallel, right? So now the case is, so now here it is R3 into R1 plus R2. Isn't it? R1 plus R2, these two are connected in series. Whole divided by R1 plus R2 plus R3. Right, then which is equal to, what about my R3? R3 is 4 rho by A into R1 is what? R1 is 3 rho by A plus 5 rho by A whole divided by R1 plus R2 plus R3. So rho by A common எடுத்துறலாமா? So rho by A common எடுத்தாச்சுன்னா 3 plus 4 plus 5. Okay, so rho by A cancel. So remaining thing is, so what about these here denominator is same. If you add the numerator means 8 rho. Correct? So 8 fours are 32 rho by A. Here denominator is whole divided by 12. So which is equal to 32 by 12 into rho by A. So that is my resistance across BC. Okay. So now resistance across AC, which is equal to resistance across AC. So for AC means only this R1, R3 are in series. So rest R2 is parallel. So R2 into R1 plus R3 whole divided by R1 plus R2 plus R3. Okay, so which is equal to, what is my R2? 5 rho by A into, here it is, I can directly add R1 plus R2, how much? 3 rho by A plus 4 rho by A. How much? 7 rho by A whole divided by, here it is as usual 12 rho by A. Okay, so rho by A cancel. So which is equal to 7 5s are 35 by 12 into rho by A. That's it. This is simple simplification only. So now I need to find the ratio. RAB is to RBC is to RCA or AC, which is equal to, RAB is how much? RAB is 27 by 12 into rho by A is to 32 by 12 into rho by A is to 35 by 12 rho by A. Okay, so in this case, whatever the common thing means, we can cancel it. So rho by A cancel. Denominator 12 is cancelled. So remaining thing is 12 is to 32 is to 35. That's it. There is no common factor between these numbers. So 12 is to, so this is 27. Okay, this is 27 by 12. Okay, so 27 is to 32 is to 35. So option B is the correct answer. Simple problem only. Okay. Right. The next problem is the power dissipated in the circuit as shown in the figure is 30 watt. The value of R is. So என்ன சொல்லிருக்கோம் ஒரு சர்க்யூட் கொடுத்தாச்சு இந்த டோட்டல் சர்க்யூட்ல எவ்வளவு பவர் டிசிபேட் ஆகுது அப்படின்னா 30 watt. Okay, so now my circuit is, so this is one resistor and another resistor is there which is 5 ohm and I don't know the resistor R. Okay, so now I need to find the equivalent resistance. Okay, so இதோட equivalent circuit எப்படி இருக்கும்? So there is a single resistor and there is one battery connection. Okay, so which has 10 volt. Okay, so this is 10 volt. Okay, so now I need to find what is my R equivalent. Equivalent resistance is what? So R equivalent can be determined as two resistors are connected in parallel. So 5R, 5 into R divided by 5 plus R. Isn't it? Directly you have to write this. Okay, so now, so this is my R equivalent. So it has some current. It is some current is flowing through this. I need to find what is the value of R. Okay, and one more data is given is power consumption. Power consumption is 30 watt. Okay, 30 watt. Here, known thing is R is known, V is known. So P is equal to V square by R. There is one formula is there. We know that, right? So now I just substitute that V square is 10 square is 100 divided by R is 5R divided by that division will be going to the top. 5 plus R will be there. Okay, so 30 which is equal 30 into 5R which is equal to 100 into 5 plus R. Right, simple calculation only. So here 6 5 3s are 15, 150 R which is equal to 500 plus 100 R. If that the 100 R will going this side, so 150 R minus 100 R, it will become 50 R which is equal to 500. Then R is equal to what? R is equal to 500 by 50, 0 cancel. Here it is 10. So what is my resistance? R is 10 ohm. That's it. Okay, simple problem. So option C is the correct answer. Okay. Now the next problem is if power dissipated in the 9 ohm resistor in the circuit is shown as 36 watt. So there is 9 ohm resistor is there now. So that power consumption of this resistor is 36 watt. Okay, so now the case is now the potential difference across the 2 ohm resistor is what? So what is the potential difference across this one? Okay, so potential difference V is equal to IR formula use பண்ணி கண்டுபிடிச்சலாம். So here resistance is known. Okay, but the current is unknown. If you find the current means everything is fine, right? So now I need to find what is my current. அதை நம்ம find out பண்றது நம்ம try பண்ணலாம். ஏன்னா potential also is not given in the problem. Okay, and the data is the consumption, power consumption of the 9 ohm resistor is 36 watt. Okay, P is equal to 36 watt. That is for 9 ohm resistor consume this much power. Okay, so now what about the potential difference between across the 9 ohm resistor? So I can say P which is equal to V square by R. Okay, so this resistance that is 9 ohm resistance. Okay, so 36 which is equal to I don't know potential across that resistance V square divided by what about my resistance is 9 ohm. So V square is equal to then 36 into 9. Okay, then V is equal to what? 6 into 3. So potential difference, I mean potential across the 9 ohm resistor 18 volt. Okay, so this is my potential across the 9 ohm resistor. Okay, this is across 9 ohm resistor. Okay, so listen, so now I easily found the potential difference between these two ends. Okay, I mean potential across the 9 ohm resistor. So what about the potential across 6 ohm resistor? Potential difference, same potential, because these two are 9 ohm and 6 ohm are parallel connection, so potential is also be same. Okay, so now V is equal to 18 volt across 6 ohm also. Okay, so now I know the potential difference between these 2 points. Okay, potential difference, potential across the 6 ohm resistor is known. Then I can easily determine. So here there is the current is I, so it is splitted as I1 and I2. Okay, so I1 can be calculated as I1 which is equal to V by R. Correct? So what about my potential is 18 divided by what about my resistance, that is 9 ohm. Okay, so what is my I1? I1 is 2 amps. I1 is 2 amps. What about my I2? I2 is equal to V by R. So V is nothing but potential is same as usual, 18 divided by resistance B 6. So which is equal to 3 amps. So I2 is equal to 3 amps. Then I is equal to I1 plus I2. So which is equal to 2 plus 3 is equal to 5 amps. Isn't it? Current level of flow of 5 amps. இப்போ எனக்கு இந்த 2 ohm resistor இருக்கு இல்லையா? So the 2 ohm resistorல எவ்வளவு current flow ஆகுதுன்னு தெரியும். V is equal to IR. So அப்ப எவ்வளவு current ன்னு தெரியும், 5 amps into எவ்வளவு resistance 2. Okay, so which is equal to 5 2s are 10 volt. Okay, so what about my voltage is 10 volt. Okay, potential difference, potential across a 2 ohm resistor is 10 volt. Okay, simple problem only. Okay. Right. So now the next problem is important problem. A wire of a resistance 12 ohm per meter. Okay, for 1 meter it has how much resistance? How much resistance is 12 ohm? Okay, is bent to form a wire of resistance 12 ohm per meter is bent to form a complete circle of radius 10 centimeter. Okay, so it forms a circle which has a radius is 10 centimeter. Okay, so now what is the total length of the wire? So length of wire is equal to what? Length of wire is equal to, that is the circumference of the circle, that is 2 pi into r. Okay, so 2 pi into, what about my radius is 10 centimeter. So 1 centimeter is equal to 10 to the power of minus 2 meters. So here it is 10 to the power of minus 1 meter. Okay, 10 centimeter means 10 to the power of minus 1 meter. So which is equal to 2 pi into 0.1 meter. So which is equal to 0.2 pi meter. So this is my length of wire. Okay, 0.2 pi meter. So 1 meter it has a resistance of 12 ohm. What about the 0.2 pi meter? So this is the total length. Okay, total length. Okay, right. So this is there. Okay, now the question is the resistance between its two diametrically opposite points A and B is shown. Okay, so now the resistance across. See here, what about the half of the ring is occupied? So this is a point A and this is a point B. Okay, so this is the diameter also. Okay, it divides the divides the circle into two half portions, two semicircles. Okay, so now what about my resistance for each part? That is the question. Okay, each part, what is the resistance? Okay, resistance between A and B, that is the question. Okay, so resistance between A and B means how much length, the length of wire is length of wire in semicircle. Okay, so it is like, see, there is a point A and there is another point B. Okay, so here there is 1/2 wire which has some resistance B R1 and another wire is there which has some resistance R2. These two are connected in parallel. That's it. Okay, so now I have to find what is my R1, what is my R2 parallel connection. I need to find the equivalent resistance. That's it. Okay, so now semicircle means it is a half of, pi into R. That is a R, circumference. Okay, perimeter of a semicircle is pi into R, which is nothing but 0.1 into pi meter. 0.1 into pi meter. Isn't it? So now I can easily find the cross-sectional area is same. Cross-sectional area is same. So R1 can be determined. R1 which is equal to, R1 is equal to what? Rho L by A. Isn't it? Rho L by A. So now the case is, see here, for 1 meter it has a resistance of 12 ohm. 1 meter it has a resistance of 12 ohm. So for 0.1 pi meter, how much resistance it will be there? Direct proportionally. Okay, direct proportionally. So for 0.1 pi meter, its resistance is 12 into 0.1 pi. Isn't it? Isn't it? This is correct only, direct proportionally. Okay, so which is equal to how much? 1.2 pi ohm. So this is R1 is equal to 1.2 pi ohm. So similar, R2 is also equal to 1.2 pi ohm. So already we know that resistance which are identical, okay, which are identical but parallel connection. What is my identical? R by N, that is my formula. Okay, R is the resistance, identical resistance, and N is number of equal resistance, number of resistance. Okay, so here what is my resistance value? 1.2 pi whole divided by number of resistors is 2. Okay, so which is equal to 0.6 pi ohm. So that is my R equivalent. Okay, so that is my equivalent resistance is 0.6 pi ohm. That's it. Okay, so now the next problem is, in the given circuit, the current through the 4 ohm resistor is given as 1 amp. Okay, so this is given as 1 amp. When the point P and M are connected to the DC source, listen, so now this is connected to the DC source that is given in the question. Okay, so this is connected to some DC source. Okay, right. So now the potential difference between the point M and N is. So I need to find what is the potential difference between. So there is the point N and there is the point M. Okay, so in between there is one resistor is there. So now the resistor is 1 ohm. So I need to find what is the potential across the 1 ohm resistor. That is the potential difference between M and N, right? Right. Now in this case, if I know the current through this 1 ohm resistor means I can easily find V is equal to IR is my formula. I can put directly into the formula. So எனக்கு answer கிடைச்சிரும் கரெக்ட்டா. So இங்க I யோட வேல்யூ மட்டும் தான் unknown, R வேல்யூ 1 ohm, that is clear. Okay, so இப்ப I யோட வேல்யூ கண்டுபிடிக்கணும். Okay, so இப்ப இந்த P and M என்ற பாயிண்ட் பார்த்தோம்னா, so மேல ஒரு கனெக்ஷன் போகுது, கீழ ஒரு கனெக்ஷன் வருது, கரெக்ட்டா? So மேல ஒரு கனெக்ஷன் and கீழ ஒரு கனெக்ஷன். Okay, so அப்ப இந்த terminal and just these two, one terminal and this one terminal. So these two terminals are parallelly connected. Okay, parallelly connected. So now it has some current I1 and this has a current I2. So now my case is I need to find what is my I2. That's it. Okay, that is my case. Okay, so now the potentials, these two are parallel means the potential across these 2 points is same. Potential difference is same, right? So now the case is the given data is through 4 ohm resistor 1 amps current is flowing. See, through this is my 4 ohm resistor. So through this resistor 1 amps current is flowing. So now what about the potential difference between across the 4 ohm resistor? What is my potential? So I can use directly V is equal to IR formula. V is equal to IR. So what is my I? 1 amps into what about my resistance is 4. So what is my voltage? 4 volt. Okay. So between these two terminals, see, between these two terminal. So just I will highlight with the green color. So between these two terminal, its potential is 4 volt. Okay, 4 volt. There it is 4 volt means here it is also 4 volt. Okay, so here same wire now, so everywhere it is same wire, same wire. Okay, so what about the point P and M? Okay, here it is also same wire, same wire, same wire. So across P and M, so this is my point P and this is my point M. So across these 2 point P and M is the potential difference is 4 volt. Okay, right. So now my interest is I need to find this I2 here. This is my I2. If I know the I2 means I can easily solve the problem. Okay, so here there one resistor is there, another resistor is connected parallel. These two are parallel connection, and one resistor is there. So this is my current is flowing. I2 is current is flowing through this. Okay, so now see this is a simple line. Okay, so through that one I know the potential difference. I know if I know the equivalent resistance mean I can easily calculate the current, isn't it? So these two are identical resistance, 0.5 ohm. This is also 0.5 ohm, identical resistance connected in parallel. So what about the R equivalent for this case is 0.5 ohm is my resistance by 2, which is equal to 0.25. Isn't it? That is my R by N formula. R equivalent which is equal to R by N formula. Right. So that is my R equivalent is 0.25. Okay. So here one ohm resistor is there. So this 0.25 and 1 ohm are connected in series. Okay. So now this circuit is become, so this is my point P and this is my point M. Okay. So across this P and M, voltage is, potential difference is 4 volt and its equivalent resistance is 1.25 ohm. Isn't it? So 0.25 plus 1 is 1.25 ohm. Now I can, the current flowing through the circuit be I2. Right. So now V is equal to IR formula only. So which is equal to I is I2. That is I need to find I2 into what about my R? R is 1.25. 1.25. Here what about my V is 4. Okay, then I2 which is equal to 4 divided by 1.25. Okay, so 1.25 I'm just writing 125 divided by 100. So that 100 will goes up. Okay, I don't want decimal, so I'm just replace that. Okay, so 100 means 425 are 100. Here 525. Okay, so 4 4s are 16 by 5 amps. So this is what is my I2. I2 is 16 by 5 amps. Now our route is clear. Okay, so here what is my requirement is V is equal to I2 into R. That is my requirement. Here I2 is found. Okay, 16 by 5 into what about my resistance is 1. So which is equal to, if you cancel it means 3 5s are 15, balance 1 0.2. Okay, so this is my volt. So 3.2 volt. Option B is the correct answer. Okay, so very simple. Analysis should be clear. Okay, clear நம்ம வந்து analysis பண்ணோம் அப்படினா ரொம்ப simple problem solve பண்ணிடலாம். Okay, right. So now the next problem is a current of 3 amps flows through the 2 ohm resistor. So here there is a current which is flowing through the 2 ohm resistor, that is 3 amps. Okay, and the power dissipated in the 5 ohm resistor is what? What about my power dissipation? What are the power consumption of this 5 ohm resistor? Power consumption means here whatever the power consumed by resistor, that is dissipated. Isn't it? That is dissipated as energy. That is what is energy? Heat energy. It is dissipated as heat energy. So power dissipation which is equal to, I know the formula V into I. Okay, one formula is V into I. Another formula is I square into R. I square into R. Okay, so here the case is, see here 5 ohm. Yes, resistance is known. What about the current? If I know the current means I can easily find the power. Right. So here the current is unknown here. Okay, so here it is 3 ohm is going on through the 2 ohm resistor. So what about the potential difference here? Okay, for see there is 2 ohm. So through this 2 ohm there is 3 amps current is flowing. So what about the potential across these two ends? Across the 2 ohm resistor. So V is equal to IR. So which is equal to 2 into 3, which is equal to what? 2 into 3, 6 volt. Isn't it? I current is 3 and resistance is 2. 2 3s are 6 volt. So this is 6 volt. Okay, so potential difference is across this one is 6 volt. Same potential, because parallel connection, same potential will be maintained here, here, here. Isn't it? Same potential is maintained. So now our requirement is this is, there is 1 ohm resistor is there, and another thing is 5 ohm resistor is there. Okay, so now the potential is for this case is potential across this link is 6 volt. Okay, 6 volt. Now I need to find what is my current is there. Okay, so for this case I'm just finding the equivalent resistance case. So this is my current I, potential is 6 volt. Okay, so this is my R equivalent. Okay, so these two things are connected in series only. So 1 plus 5 is 6 ohm. So what is my 6 ohm? And the current is I. This is 6 volt potential. So this is the equivalent form only. Okay, so from this V is equal to IR formula. So I is equal to V by R. So V by R. So V value is 6 by 6. So which is I is equal to, what about my current? I is equal to 1 amps. So here it is flowing 1 amps. Now I found the current through this link is 1 amps. So I can use the formula P is equal to I square into R. So what about my 1 square into R is 5. So which is equal to 5 watts. Okay, circuit analysis is always very simple if you are clear with the concept. Okay, right. So now the next problem is when a wire of uniform cross section A and length B L and the resistance R is bent into the complete circle, the resistance between any two diametrically opposite points will be directly previously நம்ம இத பேஸ் பண்ணி சால்வ் பண்ணிருக்கோம். Okay, so already ஒரு wire, okay, ஒரு wire which has a length BL, okay, which is now it is transferred into the circular cross section. Okay, now it is complete circular. So now what is this? Is the diametrically opposite ends. So here resistance R1, here my resistance is R2. Okay, so which is equal to here rho into L by A. So here L1 by A1. So area of cross section same. Okay, uniform area of cross section. Here R2 is rho into L2 by A. So L1 L2 get varied. Okay, already we know that we are aware of this problem. Okay, so here what about my L1? L1 is nothing but pi into R. L2 is nothing but pi into R, isn't it? So then R1 which is equal to rho into pi R by A. And what about my R2? R2 is rho into pi R by A only. So both are identical resistance. Identical, and as well as both are parallel connection. Correct? Parallel connection mean R equal and identical means R by N use panikalama. What about my resistance value is rho pi R by A whole divided by 2 resistance by 2. Okay, when you simplify you will get rho pi R by 2A. Okay, rho pi R by 2A, right? So this is my case. I can write as 1 by 4 into rho 2 pi R by A. See, I'm just multiplying the numerator and denominator by 2. Okay, so now the initial case is there is a wire of cross section A and length BL. So initial resistance B rho L by A, isn't it? So here it is also A only, small a, that is given in the question itself, which is equal to, listen, this length L is formed into the circle, isn't it? So definitely rho into this length is nothing but 2 pi R whole divided by A. Okay, so here it is rho into 2 pi R by A is there, na? So which is equal to 1 by 4, that is my R dash. So that is my initial R naught. So this is my initial radius R naught. Okay, so the initial radius be R, it is given. So resistance is R is given, it is given itself, it is question itself, it is given. So what about my R equivalent? R equivalent is 1 by 4. I mean the resistance between the diametrically opposite point is R naught by 4. So first option is correct. Already we have solved one problem regarding this concept previously. Okay, simple thing. Okay, right. So now the next problem is resistance N and each of radius R ohm when connected in parallel give an equivalent resistance of R. So resistance N, okay, N, each R, N resistance are there, each are R ohm are connected in parallel means my R is equal to R by N, right? R by N. So this is already we know that it is also given, okay, R by N. And if these resistors were connected in series, these N resistance are connected in series mean what about my R dash? R dash is equal to what? So R dash which is equal to N into R, isn't it? N into R, because series connection. Right, now the relation is simple. So I know from this case I can put R is equal to small r is equal to capital from this one, small r is equal to N into capital R, isn't it? That is a parallel connection. So when you substitute it means N into capital R which is equal to N square into R. So N square into R, option A is correct. Simple problems. These are very simple problems. Okay, right. So this is for parallel one. So this is for parallel one. And this is for series one. Okay, right. So these are the very simple problems, right? So now the next problem is the current in the given circuit is, so they are asking what is the current. Okay, so for that case you need to find the equivalent resistance. So this மாதிரி circuit எனக்கு simple ஒரு resistance உள்ள circuit வேணும். That's it. அப்ப எனக்கு current easy என்னால கண்டுபிடிச்சிட முடியும். So this is the current. So எவ்வளவு 4.8 volt இருக்கு. So I need to find what is my R equivalent. So 3 resistance இருக்கு, அது ஒரு resistance தான் நான் மாத்தணும். Okay, right. அப்ப ஒரு ரெசிஸ்டன்ஸ் நம்ம ஒவ்வொரு ஸ்டெப்பா தான் மாத்த முடியும். பாத்தீங்க அப்படின்னா இது ரெண்டும், சோ ரெண்டுமே சீரிஸ்ல இருக்கு. கரெக்ட்டா, ரெண்டுமே சீரிஸ்ல இருக்கு. ஓகே, அப்ப என்ன ஆகும்? சீரிஸ்ல இருந்தா நம்ம டைரக்டா ஆட் பண்ணிக்கலாமா? 6 + 6 12 ohm. கரெக்ட்டா? சோ அத நான் எப்படி ஆட் பண்ணிக்கிறேன்னா 6 + 6 that is 12 ohm. So that is a series connection is over. And one more connection is there is 3 ohm that is connected parallel with that one. Okay, so this is my terminals. Okay, so which is connected with a 4.8 volt. 4.8 volt. So now what about my R equivalent? So R equivalent which is equal to multiple. So direct formula, 2 resistance will be 12 into 3 divided by 12 plus 3. So which is equal to 12 into 3 is, so just keep as it is, 12 into 3, we can cancel it. Then 12 plus 3 is 15. So 3 ones are 3, 5 3s are 15. Okay, so which is equal to 12 by 5. That is my R equivalent. 12 by 5 ohm. So now I found R equivalent is equal to 12 by 5 ohm. Okay. So now I can easily find the current. So I is equal to V by R. Okay, so what about my V? V is 4.8 volt divided by, so here it is 12 by 5. Okay, so just 12, 5 on the மேல போயிடும். Okay, fraction on the மேல. Okay. So cancel பண்ணோம்னா 4 table பண்ணோம்னா this is 1.2, here it is 3 4s are 12. Okay, 3 4s are 12. So again cancel பண்ணோம்னா here it is 1 3s are 3. Here it is 4 3s are 12, 0.4. Okay, so then I is equal to 0.4 into 5, that is 2.0, 2.0 amps. So option D is the correct answer. Okay, right. The next problem is, what will be the equivalent resistance between the 2 points A and D? Okay, so here this is my point A and this is my point D. So now I need to find the equivalent resistance. Equivalent resistance எப்படி கண்டுபிடிக்கணும் பார்க்கணும், கரெக்ட்டா? So கவனிடா, இப்ப நான் equivalent resistance, let me take current is flowing like this. Okay, current flow ஆகுது. இப்போ எனக்கு தேவையான டெர்மினல் A and D, கரெக்ட்டா? A and D. அப்ப இந்த B டெர்மினல் C டெர்மினல் இருக்குல, which is somewhat in air. Okay, so அங்க வெளில இருக்கு. அப்ப இந்த ரெசிஸ்டன்ஸை இக்னோர் பண்ணிடணும். Okay, இது மாதிரி டைப் ஆஃப் கனெக்ஷன். Okay, இது மாதிரி டைப் ஆஃப் கனெக்ஷனுக்கு இது ரெண்டையும் இக்னோர் பண்ணலாம். Okay, because current flow எப்படி இருக்கும்னா, so like this, இங்க போகாது, so it will be come like this, come like this, come like this, come like this. That's it. A to D க்கு வர பாத் மட்டும் தான் பார்க்கணும். A to D க்கு வர பாத், that's it. So rest of the path you can neglect it. So now the circuit will be like this. This is one 10 ohm, and there is another 10 ohm, there is another 10 ohm, another 10 ohm, another 10 ohm is there. So here end with another 10. That's it. So this is my point A and this is my point D. Okay, so here it is 10, here it is 10, everything is 10, 10, and here it is 10, here it is 10. So now the equivalent resistance can be easily calculated. So these two are series, right? So this is 20. Okay, here it is also 20, right? So it is connected with a 10 ohm, and here it is 110 ohm. Okay, so now it is simple. See here 20 and 20, which is parallel connection, identical resistance. So 20 by 2, which is 10 ohm only. 10 ohm, 10 ohm, and again it will become 10 ohm. So this is the point A and D. So totally how much? It is 30 ohm. Series mean add everything. So 30 ohm is the correct answer. Okay, so I hope this parallel connection is clear for you. Okay, identical resistance formula is what is my R equivalent, which is R by N. So R is 20 divided by 2 resistors. 20 by 2 is 10 ohm. That's it. Okay, so very simple connection, and option A is correct. Okay, so now the next problem is, two wires of same metal have the same length, but their cross sections are 3:1. Okay, so and they are joined in series. Okay, and the resistor of thicker wire is 10 ohm. The total resistance of the combination is. So there is two wires. Okay, so there is same length L and L. Okay, here there is one is have a thicker cross section, another has a smaller cross section. So this is my A1 and this is the A2. Okay, and the ratios are given. Okay, cross section area A1 by A2, that ratio is given as 3 by 2, 3 by 1. Okay, 3 by 1. Okay, now they are connected in series. Yes, series mean it has the resistance R1, it has the resistance R2. What is my equivalent resistance? Total resistance they are asking. That is my R1 plus R2. Okay, R1 plus R2. Okay, now listen, R1 is equal to, R1 is nothing but rho into L1. Rho into L is same, divided by, here it is A1 plus here it is rho into L divided by A2. Okay, so what is my R equivalent is rho into L is total length is 2L. 2L. So now I need to find just R equivalent only. Okay, R equivalent only. Okay, right. Then from this I can get a rho can be get out. Okay, rho can be, we can remove out of this. Right. So these are the given data. Now one more data is given. R1 is given as 10 ohm. Okay, R1 is given as 10 ohm. So what is my resistance formula? Resistance is rho into L upon A. Okay, here rho constant, L constant. What about my area of cross section is a variable. So R is proportional to, inversely proportional to area of cross section. Okay, so now I can easily solve this problem. See, R1 is proportional to 1 by A1, isn't it? And R2 is proportional to 1 by A2. Okay, now divide these two things. If you are dividing these two things, mean the proportionality will be cancelled. So from this, R1 by R2, which is equal to A2 by A1. A2 by A1, because fraction by fraction is reciprocity. That's it. Okay, so this is A2 by A1. Okay, already we know that A1 by A2 is 3 by 1. So then R1 by R2, which is equal to 1 by 3. Okay, so R1 is given as, see, R1 is given as that 10 ohm. And what about my R2? R2 which is equal to 3 times of R1. R2 which is equal to 3 times of R1. So which is equal to 3 into, what about my R1 is 10, which is equal to, so which is equal to 30 ohm. So what about my R2? R2 value is 30 ohm. Now these two things are connected in series, right? These two things are connected in series. So I can easily find total resistance R equivalent, which is equal to R1 is what? R1 is 10 ohm plus R2 is 30 ohm. So answer is 40 ohm. Simple problem only. Okay, so 40 ohm is answer. Okay, so logical நம்ம think பண்ணோம் அப்படினா எல்லா ப்ராப்ளமே ஈஸியா சால்வ் பண்ணிர முடியும். Okay, right. Now the next problem is the last problem in this video. So in the network shown in the figure, each resistance is 1 ohm. Okay, what is the effective resistance or equivalent resistance? Okay, so this is symmetrical network. Listen, symmetrical network na ipo ellame 1 ohm resistor da. Idu nama இந்த பாயிண்ட்ல நம்ம இத செப்பரேட் பண்ணோம் அப்படினா ரெண்டு சைடுமே அத சேமா இருக்கும், ஒரே மாதிரி இருக்கும். That is called a symmetric network. Okay, so அதுவே சிமெட்ரிக் நெட்வொர்க்கா இருக்கும்போது அந்த வயர் ஜங்ஷன் அந்த லைன் வழியில இப்ப நான் ஒரு லைன் இந்த இடத்துல வரையறேன். சோ அதுல தான் வயர் ஜங்ஷன் கனெக்ட் ஆயிடுச்சு, அந்த கனெக்ஷன் நம்ம ரிமூவ் பண்ணி விட்டுறலாம். ஓகே, அப்ப இந்த சர்க்யூட் நம்ம எப்படி மாத்தலாம் அப்படினா, so this is the circuit, this is there. So here I am just changing. Okay, this is the modification I'm doing. So I'm just to remove the connection, because whatever the current is coming through this, that will be going that way. Whatever the current is coming through this, that current will be going that way. Okay, so that connection is not required at all. So here also, whatever the current is coming, that will be going that way. So here it is same, isn't it? So this is same only. So we can remove the connection. If you are removing the connection, the circuit will not be affected. That's the concept. Okay, so now this is 1 ohm, and this is 1 ohm, and this is 1 ohm, and here it is 1 ohm, and here it is also 1 ohm. So now these two are in series. These two are in series. So 2 ohm, and these two are in series. So the circuit will become. So here it is in series, right? So these two are series. So this is 2 ohm. Okay, this is 1, 1, 1. Okay, and here it is also 2 ohm. Okay, so this is the point A, and this is my point B. Okay, so now these two are in parallel. These two, 1 ohm and this 2 ohm is parallel. So the circuit will become, what is my equivalent? 1 into 2 divided by 1 by 3. 1 plus 2 is 3, isn't it? So two resistors connected in parallel. Directly you have to multiply these two things divided by adding these two things. 1 ohm and this is 2 ohm is there. Okay, so here it is 2 by 3, right? This value is 2 by 3. This is 1, this is 1, and here it is 2 ohm. So 1 plus 2 by 3 plus 1. So totally 2 plus 2 by 3. So which is equal to how much? 2 3s are 6. 6 plus 2, 8 by 3. Okay, so for the series connection, total resistance is 8 by 3, and here it is 2 ohm. So now it is equivalent to, there is two resistance only. One is 8 by 3 ohm, another thing is 2 ohm. 2 ohm. Okay, so now what is my R equivalent? So this is parallel connection. So 2 into 8 by 3 upon 2 plus 8 by 3. Okay, so 2 into 8 by 3, 16 by 3. So that is my R equivalent, which is equal to 16 by 3 into, here cross multiple means 3 to 6, 6 plus 8 is 12, 12 by 3. So it will become 3 by 12, because denominator fraction, if it is coming to the numerator, means it will reciprocate. So 3 3 cancel here, 4 4s are 16, here 3 4s are 12. So 4 by 3. So option A is the correct answer. Simple problem only. Okay, just solving the parallel or series, that's it. Okay, rest everything is whatever as usual we are doing that. Okay, so almost we are seeing nearly 20 problems. I hope you get the clear idea what is the particular part they are asking, isn't it? So for the last minute preparation, you can get the clear idea what is the major part we have to revise. Okay, what is the question, what kind of question they are asked. Okay, right? So do more practice on it. You will definitely get one question from this. Out of these topic we have discussed, definitely you will get one question. Definitely இதுல ஒரு question வந்துரும். So do more practice. Okay,
I hope இந்த வீடியோ உங்களுக்கு பிடிச்சிருக்கும்னு நினைக்கிறேன். பிடிச்சிருந்தா லைக் பண்ணுங்க, ஷேர் பண்ணுங்க, சப்ஸ்கிரைப் பண்ணி பெல் பட்டன் கிளிக் பண்ணுங்க. Thank you.